I'm going to share my screen. Okay. So just a reminder, everyone, if you could just keep your microphones on mute, and this chat will be recorded and available after the presentation. You can find that on our YouTube channel. And then if you have any questions at all during the time today, just put it in the chat box, and then after Wesley and my presentation, we will just answer them all at the end. Just quickly, some upcoming urban chats going on in Warren County. So we have started a development digest. So just like a blog here we do at the office, you can check it out on our website if you're interested in learning more about stormwater or any compliance that goes along with that. Like I said, past urban chats can be found on our YouTube channel. And if anyone has any ideas or topics for future urban chats, definitely feel free to send them my way. Couple Warren County upcoming events we have going on that I think you guys might be interested in. So we have a pond clinic coming up here in June. That'll be combined effort with Green and Warren County Soil and Waters. Just a way to learn more about management, maintenance of a pond. Also, this will be tailored more towards, the general homeowners, or even looking at maintenance issues for detention and retention basins. So there is a bit of an urban aspect in that as well. Also, we're doing a Women for the Land. This is just a series geared toward women who are taking care of our land. Again, these programs are free, but we just ask you to register. Just call our office, if you have any questions on these programs. And just quickly, we have a couple changes to our submittal process here at the office. So you can now do online submission through our website. We now have a tab that you can see at the top of our website labeled permits. Go in there and then you will see all the directions where you can submit them. We now require sediment basin calculations, so the compliance tool, which is what we'll be talking about today. The drainage area map, a soil map, and then your O&M documents for post-construction. Also, to touch on that, sometimes floodplains are in these areas as well. You can also find the floodplain applications in the permits tab as well. So real quickly, I'd just like to introduce Wesley Sluga from Ohio EPA. Wesley is a member of the Stormwater Technical Assistance Team with the Ohio Environmental Protection Agency's Division of Surface Water. He graduated from Cornell University in 2019 with a Bachelor of Science in Environmental Engineering and a minor in Climate Change Science. He is currently pursuing a master's degree from The Ohio State University. Wesley is a registered engineer in training and is in pursuit of his professional engineering license. He has been with the Ohio EPA's stormwater program since 2019, where he works to assist internally and externally through training, development of guidance material, plan reviews, and answering the many stormwater questions that come his way. So with that said, Wesley, take it away. I'm going to stop sharing.
Thank you so much, Emily.
So feel free to
share my screen. All right, let's start presenting from the beginning. Okay. So hopefully everybody can see that. And yeah, I'm going to talk about, confirm, Emily, we're good?
Yes, everything's good.
Okay, excellent. Yeah, I'm going to talk about the Ohio EPA compliance tools and spreadsheets that we've got available for anyone. External, that might be designers, that might be engineers, developers, or our MS4 partners as well to help. So these worksheets, they're designed to help the review side of project compliance with our construction stormwater general permit. And they're not really design tools, they're much more compliance tools. And I'll talk a little bit more about that in a minute. And one of our big pushes is we've got a lot of different design guidance and requirements in our rainwater and land development manual, but it can be hard to piece all of that information out. So we put these tools together to kind of have a concise location where you can check specific things to make sure that your designs are all in compliance, or the designs that are submitted to you are compliant. So it's a great way to facilitate this communication between an engineering designer and the reviewer, which might be the MS4 in Warren County's case. I'll say it a lot, but we always welcome input. So if you've got ideas on how to improve these tools, if you've seen bugs when you're working on them, or perhaps new tool ideas, if you think something would be really helpful, please reach out or ask questions if you've got them. Our goal is to serve the community, and that is you. So let us know if you've got thoughts. So the 4 tools that I'm going to cover here today, I'm going to work through in order of the construction process. So we'll start with our Sediment Basin Compliance Spreadsheet. This is a tool that I built, and it's for checking your active construction sediment basins and traps for their compliance with our design standards from the RLD and from our permit requirements. The next one I'll cover is our water quality volume calculator. This is for an entire site's water quality volume, not for a specific BMP. Don't worry, I'll hammer that home when we get to that. So this is perfect for new development or even redevelopment projects. That's one perk of that calculator. Then I'll talk about our BMP Compliance Worksheets, and those are for each of our post-construction BMPs. Again, checking them for being compliant with our RLD design standards and any permit requirements. And then I'll wrap up with our Runoff Reduction Spreadsheet, and that's for calculating the amount of water quality volume that's provided by our runoff reduction practices. It's not as much a compliance check like the BMP compliance tool is, more just for provided water quality volume. So before I get there, I think it would probably be a pretty good idea to give you a roadmap on how to access all of these great spreadsheets and tools. So step 1 is to navigate to our Ohio EPA stormwater webpage. That can be done by, typing in this great big long link. I'm sorry that it's so long, but your other option, of course, is always to just put Ohio EPA Stormwater Program and search it in your browser. And that'll come up pretty quickly. Once you get on the page, you're going to go to step 2, and you need to scroll down until you can see those tabs. You'll select the Construction Activities tab, and then move to step 3. You can see the third drop down is the Technical Assistance drop down. And then we can scroll down to step 4, which is our tools and spreadsheets. You can see them listed out there. All 4 are there as links. When you click on that link, it'll just automatically download a copy of these Excel spreadsheets. So as I said, let's start with our sediment basin tool. So for organization, and a lot of these tools work pretty similarly. They have an introduction tab at the beginning, and then a bulk component where most of the work is really done, and then something like a regulatory guidance tab at the bottom. Those are the 3 tabs along the bottom. So we'll start with that introduction tab. And you can see that we'll start with some disclaimers, some important disclaimers. The first one is a portion of the sediment basin sizing tool has to deal with skimmer selection and sizing, and most skimmers tend to be proprietary devices. So I want to clarify that the Ohio EPA doesn't require or recommend a specific type or brand of skimmer to be used. And simply because a skimmer is included in this tool is not an inherent endorsement or approval of that device. Each skimmer needs to be designed specifically for the basin that it's being used for. Because the outlet that's provided in the basin needs to meet the requirements of the permit. And that's pretty much to dewater from the surface at a required drawdown rate. And almost any skimmer can do that if designed properly. I've also got some basic instructions. For example, we want one of these to be completed per basin. And then we want you to put it in the SWP. So for each basin that you've got, you put one in the SWP. Really, the only thing that needs to be put in is the basin sizing and dewatering tool tab. The introduction and regulatory guidance tab isn't going to provide a lot for a reviewer. And we also suggest some other information. Emily kind of talked about it a little bit, but we recommend you've got your basin spec sheets in your SWP, as long as a drainage area map and any other documentation that's going to help that construction and review process. Additionally, on the introduction tab, I'll keep reminding that these are compliance check tools to aid designers and reviewers. They're not a design tool, so they don't account for local peak discharge or flood control regulations or embankment design to ensure you've got a stable bank if you're using a basin or something. So if you find something that is amiss, every one of these worksheets is going to have some contacts that you can reach out to. So you can see my name and my email there, as well as Justin Reinhardt, the other engineer that I work with, his contact. And then we've got a quick cell key that are color coded, and it's going to apply to all four of the tools that I cover today. The green cells are our data entry cells. So those are the only cells that are unlocked that the user can manipulate and interact with. All the other cells are locked to prevent editing or moving or kind of messing up the calculators. Those yellow cells are constant value cells. For example, like equation coefficients will be marked in yellow. While our gray cells are calculation cells, that's where our equations compute the different results based on the entries that you put into those green cells. And then lastly, we've got our red hashed cells. And those are our design check cells. And those are going to indicate whether or not your inputs result in meeting the design criteria. And they're either going to display a great big okay or a not met. And that'll tell you if you need to go back and try something again, redesign it, or if you're good to move on. And then we've also got some links there to some helpful places like the construction general permit, the rainwater and land development manual, and then our SWP review checklist. That's something that I use when I'm reviewing a plan. And then lastly, at the bottom, we got some printing guidance. And this was an example of community feedback, which I really appreciated. The original format of the spreadsheet didn't really fit onto pages very nicely, but because I got some feedback on it, I was able to change the page orientation. You need to make it landscape mode. You restrict your margins, and this will neatly print off into a PDF, or you can print it off so that you can use it for your reviews. Now, the basin sizing and dewatering tool tab, this is the bulk. This is where the action happens. And the first step is always going to be to fill out your project summary. I can't stress enough the importance of selecting the correct watershed and properly entering the total and disturbed areas for the drainage areas for these basins, because the rest of the spreadsheet is going to build off of that information. So you want to double check that you're starting out right, and you've calculated your drainage areas properly. A drainage area is a product of land features and topography. It doesn't end at the site boundary. So you've always got to check for off-site run-on. And the watershed selection, I'll just note that's important because there's a special watershed in central Ohio, the Big Darby Creek, and it has special different volumetric requirements. But if you're anywhere outside of that watershed in the rest of the state, then you'll just use the standard statewide drop down. Now you can see that on the right-hand side, there's strings of black text that extend to the right of many of the cells. This is guidance text, and it helps to indicate what format we might want entries in the green cells. It might give you an example of what calculation is being done in the gray cells, and then any requirements that are being checked in those red hashed cells. So when you get into step 2, that is where your eyes might naturally be drawn over to our pretty awesome basin schematic that helps visualize the information that you provide in these steps. But the important part are step 2 and step 3, which is where you enter your stage storage table and your outlet elevations. So it's vitally important, I need to emphasize that it's vitally important that the exact skimmer outlet or stop elevations and secondary outlet elevations from step 3, those also need to appear in the stage storage table. Because if they're not in there, then the spreadsheet isn't able to compute the provided volumes and is not going to give you that sought after okay in the compliance check cells. So if you're getting an NA or a not okay message, that's the first thing that you need to check, is to make sure that those elevations are replicated in the stage storage table. But another example might be that your secondary outlet invert is so high that the depth of the dewatering zone, that's that blue section in the basin schematic, maybe that's more than 5 feet, and that is a maximum from our rainwater and land development manuals. That might be another reason why you might get the not okay readout. Now, step 4 of the spreadsheet is the skimmer selection and sizing process. So the first thing is going to be to select which skimmer is going to be used. The options are listed there in alphabetical order. So if you, for example, select the Delaware DOT skimmer, then this a built-in calculator is going to appear below, and I'll show you that on the next slide. But if another option is selected, like the ESC, the Faircloth, or the Marley float skimmers, then the spreadsheet is then going to direct you to a link that takes you to the calculator that's provided by the manufacturer. Now, I'll note that if you're checking or you're filling this information out, to check to whether you're using the required or provided dewatering volume when using those online manufacturer calculators. Some of them seem to suggest you should use the provided dewatering volume, but you really should be using the required dewatering volume. And lastly, the last section is to input the orifice diameter size, and that's a little different than the skimmer size itself. So very often the calculator or the manufacturer calculators might spit out that you need a 4-inch X brand skimmer with a 3.2-inch diameter orifice. So this is where we want you to put that 3.2-inch diameter orifice, because that's the restricting or the control orifice, not the 4-inch skimmer pipe itself. Because the whole goal is to provide a dewatering time that is at least 48 hours, but not greater than 7 days. So that cell there is so that when you do your calculator, you can enter in the dewatering time that you've selected to make sure it fits in that requirement. Now, if you're using a skimmer that I didn't mention already or doesn't appear in the dropdown, we do have an other option, and then you can fill it out a little bit more manually. After you've selected your proper skimmer type, you're going to see these boxes pop up. So this capture is unique to the Delaware skimmer, or the Delaware DOT skimmer, because it's the only one, as I said, that has a built-in sizing calculator. That's because this calculation method is relatively simple. It's just done using the variable head method. That means the constricting orifice is down at the outlet of the skimmer pipe instead of being up in the head of the skimmer. If it was up in the head, you would just use a constant head method. But that whole conversation is described in a lot better detail in the Rainwater and Land Development Manual, if you're curious how that works. As I said, the other skimmer types don't have a built-in calculator, so you instead need to go to the manufacturer's calculator and do that sizing there. The dropdown is going to present the links to take you to those right tools, and so we recommend that you grab a screenshot of the calculator and include it in the SWP as proof that the size you selected is going to result in that desired drawdown, fits in that window. And you can see that we've got, for each skimmer type, there's a detailed spec drawing that can be thrown right into the SWP, and a photo for reference of what that skimmer is probably going to look like in the field. Again, if you pick the other option, you need to provide your own spec sheet yourself. I'll comment quickly that regulatory guidance tab at the bottom, it's really just a table summary of all the numeric requirements that are specific to a sediment basin. That's already being checked when you fill out the tool completely. But sometimes people like to have just a list so they can go through a mental check to make sure all the major design conditions have been met. And that wraps up our sediment basin calculator. So now let's get into our next one, and that is the water quality volume calculator. This tool is particularly helpful for calculating water quality volume for new development and redevelopment projects. It's not for the water quality volume for a BMP, it's instead required water quality volume for a site. So I make that distinction because this tool isn't a replacement for the BMP compliance spreadsheet. Instead, it's complementary. They work together really, really well. As always, we want you to start by entering general project details so that the tool can easily be associated with a specific project. When you get that done, now we get to the useful part of this short calculator. If it's new development, you pick the new development from the dropdown. That means the site wasn't previously developed. There's no existing impervious area that's going to be removed. So in this case, you only need to enter your total disturbed area, and that's usually identified on your plans by your limits of disturbance. It's also entered in the notice of intent. And then you'll enter in the proposed impervious surface area. That allows the spreadsheet to perform equation 1 from the construction general permit for you. And it even provides your impervious fraction, your volumetric runoff coefficients, all that stuff is done for you automatically. And then at the bottom, it's going to spit out water quality volume, both in acre feet and in cubic feet. Again, this is required water quality volume for the site. Therefore, the water quality volume that you provide in your BMPs that you design and implement should, in theory, total this water quality volume. Now, redevelopment is really similar, but it's important to understand how redevelopment works. So on the next slide, I'll kind of give you an example of how to clarify that, but we'll walk through the tool first. So just for now, I'll reinforce that you need to enter the disturbed area, disturbed being the emphasized word here, as well as existing and proposed impervious surface area that goes on within that disturbed area. When you do that, the calculator is going to perform equation 3 this time for the CGP, and it will spit out a lowered water quality volume because it's a redevelopment site. In the middle there, you can see delta R sub V, the triangle R sub V, and that's your change in volumetric runoff coefficient. If that number is negative 20 or a number greater than negative 20, then no water quality volume is required. So that's a pretty nice perk of redevelopment. But for any other combination, the water quality volume will be required, although it is going to be less than what would have been needed if this was a new development project. And we do that to kind of encourage the redevelopment of existing impervious instead of a continued sprawl of new development. a nice note down there in the message center in red text, it also calculates a minimum impervious area. Because this is a reduced water quality volume, you don't necessarily need to capture the entire site. So in this example, you got this 5-acre site, and you've got 3 acres of proposed imperviousness. Only 1.379 acres of that 3 needs to be directed to a water quality BMP. So you can kind of manipulate your drainage areas and where you direct catch basins and storm sewers so that you can provide a smaller water quality BMP. Now, I do want to note that that impervious area should be the area with the highest pollutant loads. Those are typically like your surface level impervious areas that receive a lot of traffic. We want you to capture the worst areas and treat them as opposed to capturing a roof area that is going to have a relatively lower pollutant load. So as promised, I wanted to make some clarifications on that redevelopment because it was a little bit difficult for me to understand when I joined the agency. So I could understand if it might be a little confusing to you as well. As I said, redevelopment is based on existing and proposed impervious areas within the disturbed area only. So the reason I make that distinction is because everything that goes on inside the limits of disturbance might not always actually be disturbed. That's something that kind of counterintuitive in plans. So let's say this parking lot for the shopping center is going to all be torn up and replaced all the way down to the subgrade. So it's going to need CGP coverage. That outer orange line is a 5-acre area. So you might say, oh, the disturbed area is 5 acres, but the 1-acre building footprint is not going to be disturbed. It's going to remain unchanged. We're just working in the parking area. So therefore you would exclude that 1-acre footprint of the building from the area of disturbance and from the existing and proposed impervious areas that you use in the calculator. Therefore, you're only going to use 4 acres for all 3 of those types if it's going to be totally impervious at the end. But maybe it's going to change and you'll have some stormwater basin off to the right. And maybe a grassy area. So because we use that redevelopment calculator, we could figure out what portion of the parking lot needs to drain to that basin, as we don't need the whole site to drain to that basin. Now, that wraps up our water quality volume calculator, but we're going to get into our BMP compliance worksheet. This is our biggest and oldest of our tools. And it covers BMP compliance for each one of our different post-construction stormwater BMPs. This intro slide might appear really similar to that of the Sediment Basin Compliance tool. This was the original template for that other tool. It lists the different worksheets for each different BMP. It's got instructions. We want a separate spreadsheet for each BMP. And we want it to be included in the SWP. Again, we reinforce that this is a compliance tool, not a design tool. And then we've also got contact information and our cell keys again. We'll start with our project info and water quality volume calculation tab. That's regardless of which BMP you're going to use eventually. So you enter your basic project details, you enter your drainage area, you enter the impervious portion of the drainage area to that specific BMP. And this tab is going to calculate the required water quality volume for the BMP given that drainage area. And that's probably a little different. It's probably going to be different than the water quality volume that's required for the site, which the water quality volume calculator prints out. That's usually because a site might have more than one BMP, or the BMP might have a slightly different drainage area than what the disturbed area was that we entered into the water quality volume calculator. And additionally, if you have a BMP on a redevelopment site that drains the whole site, you need to provide water quality volume based on the drainage area. So even though the water quality volume calculator might have said you could use a smaller impervious area, BMPs are all done based on drainage area. So you have to physically manipulate the drainage area if you want to shrink the BMP. So once you get data entered, you'll pick the appropriate BMP tab and continue. Now, at the BMP that you've selected is an extended detention basin, kind of like our wet, dry, or constructed wetland basins. The tabs are pretty much the same. They are laid out the same. They function almost identically. And our first big important step is step 3. That's our stage storage table. We recommend using 1 foot or smaller contours, and that way the spreadsheet will accurately estimate your incremental and cumulative volumes that your basin provides. And then in step 4, that's where you're going to enter your outlet elevations for your water quality orifice and your secondary outlets, as well as the volume of a forebay if there is one, like in a dry basin. You need both of those invert elevations because that's how you determine the amount of water quality volume that gets provided. You need to review each of those design checks on the right-hand side to make sure that they all say okay, like in this example. But if they don't, you'll check out that the guidance text on the right. Now, something that I will note in that step 4 that can be a little bit confusing is that forebay volume. There's a drop down that asks if the forebay is above or below the water quality outlet. Now, if it's obvious, if it's above or below, that's not really a big deal. But it's pretty common that, like in this example, where it's both above and below the water quality outlet. So I'll say it's not a huge, it doesn't greatly impact performance of the basin. It's a pretty minor design detail. The only thing it really affects is this permanent micropool volume provided. So if you do have a situation like this, you can always just manually determine the volume in the forebay and then subtract that out from the permanent micropool volume provided. Or you can just take the conservative approach, select yes, and make sure that the design criteria still says okay. And then you can manipulate the size of the micropool as needed to make sure you get that okay. Now, step 5 is where drawdown comes into play. The spreadsheet evaluates the outlet sizing for that water quality orifice. It's pretty neat. The spreadsheet actually gives a suggested orifice diameter, but we encourage you to alter it to fit a pretty standard size so that it's easier for the contractor to install. It might be difficult to install exactly a 1.49 inch diameter orifice. But really the big thing is long as that the outlet meets your drawdown requirements. So in this example, it's for a dry basin. That has a minimum 48-hour drawdown, but for wet basins or wetland basins, it's 24 hours. And then you've also got another component is that you can't drain more than half of the water quality volume in the first third. So that's what the second to last cell is checking there. A plot exists to kind of help visualize that drawdown. So the blue line is the drawdown of the basin in volume. And then the black dots are your standards that you need to meet. So you can see the 48-hour drawdown minimum and the no more than 1/2 the volume in the first third. And so as long as the blue line is to the right of those 2 black dots, then you're good to go. I'll also note sometimes this calculator can suggest using a really small orifice, especially if the drainage area is really small. we don't recommend using water quality orifices that is smaller than an inch. Really, we don't suggest smaller than 2 inches, but definitely not smaller than an inch. They have a tendency to clog really easily, even if you're using a mid-pool draw or an upturned elbow to help protect the orifice. So that might be an indicator. Consider altering some of your design parameters or adding additional protections to minimize your clogging risk. Now, I'm not going to go through each one of the BMP tabs in quite as much detail as the 3 basins that I already covered, mainly because there's a lot of repetition. So I'll just try to focus on the important differences. For infiltration basins and bioretention cells, there's this added component in step 2 that asks for filter bed area. You can see it calculates a minimum filter bed area there for you. This is to ensure that the filter bed area isn't too small compared to the contributing impervious drainage area. When it gets less than 5%, we tend to see situations where you can overload and easily clog these infiltrative surfaces. And suddenly you turn these infiltrating practices into these stagnant shallow ponds. The stage storage table isn't shown because it functions the same from step 3, but at the bottom of step 3, there is something that's a little bit of a twist. The spreadsheet assumes that these practices are infiltrating, therefore they don't provide a water quality orifice. It only provides the overflow invert. So this overflow invert does 2 things. First, it limits the ponding depth so that you can ensure you provide at least enough water quality volume, but also it's a check because certain vegetation doesn't tend to do well in deep, frequent inundations. So it's kind of a 2-step check there. And then in step 4, there's some unique entries for bioretention, because bioretention is a layered media practice, and the different media layers need to achieve a proper depth in order to meet the design criteria that the RLD specifies. So we'll wrap up the BMP compliance worksheet with infiltration trenches and permeable pavement. This also applies to bioretention and infiltration basins. So I kind of lumping them together a little bit here. And that's that section 1 soil suitability. So hydrologic soil group, texture, water table depth, underlying soil hydrologic conductivity, those all greatly determine the ability of a BMP to infiltrate stormwater. So if you've got clayey soils with low KFSs, they tend to be pretty poor infiltrators. So if that is the case, that might be a time to reconsider which BMP you're using, because the existing soil might not support the intended use. We do recommend attaching like a geotechnical report or document or any field measurements on how you documented KFS to ensure that things are going to meet the proof of concept. Stage storage isn't a component for trenches or permeable pavements, but do remember that all infiltration BMPs, even the infiltration BMPs or infiltrating bioretention cells, have a maximum drawdown, and it's a maximum of 48 hours, as opposed to a minimum drawdown that the extended detention practices have from before. This is a double check to ensure that constant ponding isn't going to be an issue. And then at the bottom, similarly to how bioretention has that impervious area to filter bed area ratio, permeable pavement has a surface loading ratio to help minimize any clogging risk. And then that puts us into our last spreadsheet, runoff reduction, and that includes our BMPs like grass filter strips, downspout disconnections, and grass swales and some of our other BMPs. Spreadsheet starts just like the others with a project info and summary tab. Green cells are editable. but there aren't any design check cells in this spreadsheet because it's more about providing water quality volume than it is about meeting design requirements. And then another thing that's a little different is that the tabs at the bottom are different areas instead of different BMPs, because a single drainage area could have multiple different runoff reduction practices in series. And I'll do an example to see a little bit of how that works and how this spreadsheet works. We've also got down there in orange, an area unit converter. Most designers tend to work in acres. But because these runoff reduction practices tend to be pretty small, the spreadsheet uses square feet. Each tab, area A, B, C, and D, all look and function the same. I've got this zoomed out a lot so you can see what the whole thing looks like. But when you pull it up, it's going to be zoomed in so you can only see a couple runoff reduction practices that you'll have to scroll through if you want to see the others. So it's got all the practices listed here on the left, but you only need to enter information for the practices that you intend to use. So let's work through an example to see how this spreadsheet kind of works. So imagine we've got a 0.86 acre parking lot, and we think we want to use runoff reduction to provide water quality treatment because we've got a pretty sizable vegetated area to one side that we think we can direct our drainage to. So we enter our ID label and the drainage area of the parking lot and what portion of that area is impervious. And now we'll get to our first runoff reduction practice. So if the pavement has slopes to one side and we've got a gravel verge that we're planning on using, maybe our first natural instinct would be to use impervious surface disconnection and use the simple disconnection. The site, for example, is on CD soils, as most of Ohio tends to be. And so therefore we enter the impervious area in the contributing drainage area column. So we would use that area converter tool to take 8.86 acres into just about, over 37,000 square feet. And then it's going to calculate the water quality volume that needs to be provided, 2,669 cubic feet. And then we enter into the practice portion. So, say we've got about a 400-foot long section of pavement, the disconnection length, and this first disconnection area is going to be about 20 feet wide. So it's 8,000 square feet of simple disconnection. We can see that it doesn't provide a lot of runoff reduction volume, only 160 cubic feet. So it doesn't take much of a dent out of our remaining volume. So therefore, we're going to need to use another BMP downstream. And the logical next choice is to do sheet flow to a grass filter strip. So we would select that from the drop down, and then we would scroll down and find that practice. And because we add anything into these two columns, they're already factored in from before. There's no new contributing drainage area. So then we would figure out the disconnection area or the area of the practice. Say maybe we've got 50 feet wide. So we've got 20,000 square feet of grass filter strip. It's a little bit bigger, 600 cubic feet, but we've still got more than 1,900 cubic feet of water quality volume left. So we're going to need another BMP after that. Luckily, we've got lots of impervious surface. So the only option after these two is conservation area. That's the last in line. Nothing can drain from a conservation area. So again, we don't need to add anything into the first part. We can skip right to disconnection area. And we've got a big undisturbed conservation area of trees and meadow grasses. It's 100 feet wide. So that gives us 40,000 square feet. And that's a pretty good chunk. That's 1,600 cubic feet of runoff production volume. We still got a little bit left over, just about 300 cubic feet remaining. So there's no more downstream practices that we can use. So we might need to reevaluate the layout, the different proportions. Maybe we could use less simple disconnection area and increase the conservation area to try and meet that full requirement. Or maybe we need to consider using a structural or traditional water quality practice, or BMP. And after you fill out that tab, you're going to go back to your summary tab, and you can see all the information for each one of the different areas all in one nice, neat place. It's going to show your drainage area, impervious fractions, water quality volume that was required, how much you provided in runoff reduction volume, and then what you've got left over. And then you've got that down at the bottom in project totals. You can see it for all the different areas combined. And that pretty much wraps up my portion of the presentation. So I'm going to pass it back over to Emily to continue the discussion on NOTs, and we'll have plenty of time for questions at the end. Thank you.
Sounds great. Thanks, Wes.
You're very welcome.
Go back to sharing my screen. So now on to filing a notice of termination. So this is something we get a lot of questions on in our office. And just for reference, I focus on areas of the county such as South Lebanon, Union Township, Village of Morrow, Hamilton Township. So if you have maybe any specific questions for those MS4s, definitely feel free to leave it in the chat box. Or even if you have just a general question for any other area in the county, I'm happy to answer that as well. But just to get started, so filing an NOT, this typically begins when the site is nearly full or is nearly or fully stabilized, excuse me. So typically our inspectors, in Warren County, if we're going to look at a site, they've been inspecting it for several months now, and they will be telling the developer or the contractor, whoever it may be, now it's time to try and get it stabilized, maybe consider filing your NOT. So we like to communicate with everyone on site. And like I said, a site inspection will occur, and then all maintenance agreements will be in place. And post-construction BMPs will be maintained. So just make sure that is all taken care of before filing. And here are just some pictures throughout the county that we've taken. So the picture on the left, that would be a good example of a site that's nearly stabilized. There is some vegetation growing, but there still are some bare spots. Picture on the right would be a fully stabilized site, and that would be, ready to go and file for the NOT if it hasn't already. So when you go to file the NOT, there is a new website through the Ohio EPA, and it is on the Streams portal. And the link is right there in blue. When you log into Streams, you should see a screen kind of like the little cutout I have there on the bottom. And if your construction project is listed, then you can just click on it to access the permit. Sometimes the facility, which is what it's called on the website, or your construction project isn't listed, then you will have to click add the facility or the permit. So then once you click on that, you can click on the drop down arrow, which is circled on the left. Then you will click the blue actions button, which is then circled on the right of the screen. And then you'll select terminate. Again, if your facility was not listed under the facilities, you can click on add facility permit and then type in your permit number to add it to my facilities. And then again, just follow the instructions that I just went through of clicking on the arrow for the drop down. You can get your actions for the blue button, terminate. So when to submit the notice of termination. So you want to submit within 45 days of completing all of your permit requirements. Again, enforcement can be taken if a permittee submits the NOT without meeting one or more of the following conditions that are listed below. And this comes straight from the updated construction general permit. You can also find that on the EPA website. Just to quickly run through these bullet points. So the first one, you want to make sure that you have almost final stabilization, like I mentioned. So that's near or full stabilization on the site. And that is, the permittee is responsible for the stabilization. Again, you want to submit the NOT if another operator has assumed control over all areas of the site that have not been finally stabilized. Third point being a maintenance plan is in place to ensure all post-construction BMPs are adequately maintained in the long term. And then for this fourth bullet point, I know it's a little long, but I think the most important is highlighted in yellow. So a lot of development that we see here in Warren County is residential. So if it is a residential development, temporary stabilization has been completed and the lot, which includes a home, has then been transferred to the homeowner. Final stabilization has been completed and the lot, which does not include a home, has been transferred to the property owner, or no stabilization has been implemented on a lot, which includes a home, and the lot has been transferred to the homeowner. And again, you can find that on page 33 of the permit. Submitting the NOT form again, so the permittee will then submit a complete and accurate NOT form using Ohio EPA's electronic application form. Again, the link is there at the bottom. You can submit that through their e-business center. Submission through that e-business center, it does require establishing an account, and then you will obtain a PIN for final submission of the NOT. If you are already an existing e-business account holder, you can access the NOT form through your existing account, and then you will submit using your existing PIN that you have already. So you wouldn't have to create a new PIN or create a new account for that. Again, that link is there for you. And then alternatively, if you do have a hardship that in submitting the NOT form online, you can submit on paper, but it is provided by the EPA. There are certain guidance that you have to follow. Just in small print down there, the NOT information, it needs to be typed. But also, if you do have any questions about submitting your NOT, definitely feel free to reach out to the Division of Surface Water. Their number is provided there at the bottom. And with that, if anybody has any questions for Wesley or I, now's the time to put those in the chat box, or you're welcome to come off mute and talk. Okay, well, if we don't have any questions, I just want to say thank you everyone for joining our urban chat. And thank you, Wesley, for your presentation. We really appreciate your time today. Everyone have a nice afternoon.
Very welcome. Thank you.